All right, well, welcome everyone to another Ranchers Thursday Lunchtime Series. This is a two-session series put together by Mr. Wes Lee. My name is David Lallman. I'm a beef cattle specialist here and part of the OSU Extension system. We're a network of specialists and county educators across the state. And I like our theme on our website. It says OSU Extension helps Oklahomans solve local issues and concerns, promote leadership, and manage resources wisely. And that's what we're about here today. I'm going to ask my other two co-hosts to introduce themselves.
Hi, I'm Paul Beck. I'm also at the State Extension Office in the Animal Science Department at Stillwater. I am a beef cattle specialist focusing on growing cattle and feedlot nutrition.
Good afternoon. I'm Rosalind Biggs. I am also a beef cattle extension specialist, both with the Extension as well as the College of Veterinary Medicine. Really excited to hear our presentations today. I think we've got some great topics, particularly with, for me, we've got a lot of rain in Stillwater, Oklahoma, but back home in Chickasha, we need some. So looking forward to the presentations that Wes has put together for us.
Wes Lee is coordinator and the agriculture coordinator there in our Oklahoma Mesonet system. Just a real quick history, Wes, you can provide more detail if you would like, but he spent a lot of time in his first, we'll call it the first half of his career as an extension educator here in Oklahoma. And so he has a lot of appreciation and experience in agriculture and assisting livestock producers in particular. You'll see Wes, he is famous for his television program or part of the OSU Sunup television program that airs every Saturday morning at 7:30 and every Sunday morning. I don't watch that one, but I believe it's at 6 a.m. Wes, thank you for coordinating this two-session series, and we're looking forward to your speaker's thoughts.
Well, it's a pleasure to be here with the audience today. Thank you for agreeing to let us be a part of your Ranchers Luncheon Series. This will be a two-week series for this. We started planning this discussion back in November when it became evident that the weather pattern, the ENSO weather pattern that our first speaker is going to talk about was going to be in place pretty solidly. Of course, it's turned off a lot wetter for a bigger part of the state than we kind of expected back then, but still interesting to note that almost 25% of the state is under some type of a drought as we speak today, or some kind of drought declaration. So I won't waste any more time. We want to get right into the program. We have three speakers for you today. I'll be finishing up with the third speaker. A lot of information to present to you in a short period of time. We have one individual, Andrea Melvin, is over in the chat room. If you have any specific Mesonet questions, you can ask her as we're presenting, or we'll be able to answer questions as we go along here with the presentation. So let's start off with our first speaker. He doesn't have a camera, but I promise you he is real. We share an office here in the National Weather Center at Norman. Our first speaker will be Gary McManus. He's a state climatologist for the state of Oklahoma, going to be discussing with us this ENSO weather pattern that's kind of the basis for why we're having these presentations over the next couple of weeks. So, Gary?
All right, can everybody see that okay?
Yes, Gary.
All right, I'll get started. So we hear a lot about ENSO. Really, we hear El Nino a lot. And ENSO, of course, is the El Nino Southern Oscillation. You hear a lot of talk about it from the TV guys and a lot of the National Weather Service guys. And a lot of people just think well, it's something far away that impacts our weather. We're not really sure what it is. And since the name El Nino is in the actual title, this is what people think when they see ENSO, El Nino Southern Oscillation. Well, El Nino's in there, it's just about El Nino. But no, it's more than just El Nino. And of course, we have the La Nina going on right now. So we'll talk about just every phase of the ENSO, El Nino Southern Oscillation phenomenon. So what is ENSO? Well, ENSO, as I said, stands for the El Nino Southern Oscillation. It does have three phases: El Nino, which is probably the most famous, of course, and then La Nina, which we climatologists like to pay a lot of attention to. And then, of course, there's this neutral condition. So those three phases make up the oscillation. The Southern Oscillation refers to seesaw changes in equatorial Pacific surface pressures. That's not really important. It just says that you don't just have the sea surface temperature. We also need changes in the atmosphere. So the reason ENSO is important is that it can change the global circulation patterns. In other words, the planet's temperature and precipitation patterns. So it does that through what's called teleconnections. So changes down there, since the Earth's atmosphere is just one gigantic fluid, it does translate through the whole globe eventually. Why scientists like it? Well, it can be predicted several months and at times even seasons in advance of its possible impact. So it's good if you're looking in, let's say, June or July, and you say, well, this coming cool season, when we get into like October and then through early spring, we might have a La Nina or we might have an El Nino. Then we can start to look at what the possible impacts might be, several months and seasons in advance, and that allows people to plan a little bit better. As long as we understand that the uncertainties still exist, even when we do make those types of predictions. And ENSO does switch irregularly between the three phases every 2 to 7 years. So we don't generally have El Nino, El Nino, El Nino, El Nino 4 years in a row. We get El Nino and then a couple of La Ninas and a neutral conditions, and then, it just keeps switching back and forth like that. There are some patterns inside that irregular switching pattern, but we won't get into that today. It's a little bit too down into the weeds for that. So ENSO actually has three phases, as I said, based partly on the sea surface temperature changes in the equatorial Pacific region. So that area between, let's say, Indonesia and the west coast of South America. So El Nino famously is the warming of those waters. It's the warm anomaly at least greater than 5 degrees centigrade. La Nina will be the cooler than normal waters there in the eastern part of the equatorial Pacific. So that's less than minus 5 degrees centigrade. So in the middle there, from about -5 to minus 0.5 to plus 0.5 degrees centigrade, that's when you have the neutral conditions. That's when you just basic normal patterns kick in. So as I said earlier, ENSO is a coupled phenomenon, so it does require a certain change in the atmosphere to be classified as El Nino or La Nina. So we start with the change in the sea surface temperatures, but then we need to have the atmospheric component, that southern oscillation, the changes in the atmospheric pressure, and then changes in precipitation patterns. So that sea surface temperature anomaly without the atmospheric component is just an anomaly. So it doesn't translate the impacts as much without that atmospheric component. And as I said, ENSO does switch irregularly between the three phases every 2 to 7 years. That's so important, I guess I said it twice. So how does ENSO change weather patterns around the globe? Well, like I said, it's through teleconnections. So first, if we look at this first picture up above, it changes the pressure and storm patterns along the equator, which changes the trade winds, which is known as the Walker circulation. So it changes these airflow patterns east and west along the globe. We get some stronger than normal updrafts and some weaker than normal downdrafts. Now, when we do that, we change the Hadley circulation, which is the north-south circulation. So if we get a stronger than normal updraft somewhere, well, then we increase the flow in this Hadley cell, and vice versa with the downward flow or the downdraft. So what that does is it leads to changes in the worldwide circulation patterns, including the position of the jet stream over North America. And that's important for our weather here in the United States, because that jet stream does, by a large degree, control our weather patterns, especially when it comes to precipitation. So El Nino, the more famous of the two, El Nino Impacts. You can see here on the global scale, we get during El Ninos, big time droughts in Australia and northern South America. So when we talk about El Nino, you'll often see in the news that we have big time drought, big time heat in Australia and also in the northern part of South America. But along the southern U.S., we get the wetter than normal conditions on average. And of course, it does impact the hurricane season when we get into these phases. When we get into the El Nino, the hurricane season is worse in the Pacific Ocean, but it's better in the Atlantic Ocean. And of course, we saw this year that we were definitely not in El Nino because we had an extreme hurricane season in the Atlantic. Now, along just the United States and the North American continent, we see warmer weather in general across the northern tier of the United States, but wetter along the southern tier, dry in the upper Midwest and into the Southeast, sometimes get down into parts of Oklahoma. And we're really talking in a time frame here for El Nino, about October through March. So the bulk of the cool season in Oklahoma. I know it's not always cool in October in Oklahoma. It's not always cool in March, but that's considered the cool season climatologically. And strength does matter. When we get to the degree of that sea surface temperature change, that leads to a greater increase or decrease in those upward and downward motions and those precipitation patterns along the equator, which changes our weather patterns up here. So if we look at that El Nino precipitation, all the different variations of El Ninos from weak to moderate to strong to very strong, and again, it depends upon the sea surface temperature anomalies. We can see how those change the precipitation at least through the cool season. So if we look at, this is November to March for these particular graphs. So a weak El Nino does tend to bring us, oddly enough, drier than normal weather. So that's one thing when I'm looking at these forecasts. If I see that they're going to forecast a weak El Nino, well, that sort of piques my interest because we might end up with drier than normal weather, counter to what we think about El Ninos. And then we see moderate, again, a little bit more of the drier weather across eastern Oklahoma. Then when we get into the strong and the very strong El Ninos, that's when we start to see the impact of wetter than normal weather, at least for Oklahoma. And it shows that very well on the southern tier of the U.S., just like it's supposed to. Now, these very strong El Ninos, you probably remember the last one we had was 2015. That was what was called the Godzilla El Nino, one of the strongest on record, at least back in 1950. That was when we had the wettest year on record for Oklahoma by far. We had extreme flooding, especially across southeastern and eastern Oklahoma, but all of the state was above normal. So that the strength does matter when we get into these spaces of ENSO. Now La Nina, what we're in now. La Nina impacts. We see Australia, just it's sort of opposite. Australia benefits. In Central America and also in the Northern South America, they benefit in this case. Depending on how much rainfall they actually get, they benefit. The southern U.S. and parts of Asia and South America have the problems with the dry weather. The hurricane season is worse in the Atlantic, but better in the Pacific. So we've definitely seen this year during La Nina that we did have a much worse Atlantic hurricane season, one of the worst on record, actually, with the number of storms and the amount of damage that those storms did. Now, for the United States, once again, we see that the polar jet stream pushed farther to the north. And again, that's our steering winds. That steers those storm systems up to the north, generally away from Oklahoma. When it gets farther to the east, then it starts to dip down. So we did generally see drier and warmer weather along the southern tier of the U.S. So opposite of El Nino, basically. Weather in the Pacific Northwest and the Ohio Valley. And that can sometimes extend down into northeastern Oklahoma. And here the impacts are October through April generally. But the strongest influence of those impacts tends to be January through March. As I said, strength does matter. So it's a good lesson, though, that we do have a La Nina this year, but we have actually, we have one of the wettest December through early January periods on record. So it doesn't always work out the way it's supposed to. That's why we say, just the odds are tilted towards these types of impacts. But it's always good to prepare just in case. So for La Nina precipitation, this is basically the same type of presentation that we saw for El Nino with the different strengths. Now these should be negative, minus 0.5 to minus 0.9 for the week, minus 1 to minus 1.4, and so on. I forgot to put the negative something there, but we do see for precipitation for the week, moderate and strong, on all of those phases, or all of those strengths of the La Nina, we do see those impacting our precipitation across the state from November through March. We see those actually deficits across that time frame. And oddly enough, there's always idiosyncrasies within these. The moderate La Ninas tend to impact us a little more, at least historically. Again, when we look at the forecast for El Nino or La Nina, it's important to look at what strength is being forecast by those climatologists forecasting that. Now, we don't have a super strong La Nina category, so I threw the temperatures in there. When we get into the strong La Nina, then we start to see the bigger impact in the temperatures. We start to see the warmer than normal weather, which is important because it can start to influence the drought, because we know drought and heat do feed off each other. So when we get to warmer than normal cool seasons, that can exacerbate those drought conditions if they start to set up from the La Nina. So some important points for ENSO, El Nino Southern Oscillation. As I said earlier, impacts are more likely during ENSO events, but they're not certain to occur. So when we do see an ENSO event like El Nino or La Nina being forecast, these things are tilted in that direction, whatever the long-term impacts have been on average, but they're not certain, and we're seeing that this year. Over the long term, from October through the current time frame, much of the state is still drier than normal, but those extreme events that we had, the extreme snows that we saw, and the rain events in December have tilted at least the last couple of months to the wet side. So we still have a couple of months to go. Let me caution you on that. So while it looks like we're setting good, we still have February and March and then parts of April to get through. So always good to be cautious on that. And as I said previously, the stronger the ENSO event, the more likely the teleconnection impacts become. So the stronger the temperature difference or the temperature anomaly down in the equatorial Pacific, the stronger we see those changes in the atmosphere, and then the stronger we see the impacts up in our part of the world. And there is some correlation between strength of the event and the severity of the effects. And these are generally, as I said, cool season impacts, late fall, middle of the fall through middle of the spring, basically. It does start to, the impacts do start to diminish the later we get into the spring and later into the winter. But they do have some momentum, and they can last through spring at times. Scientists have low confidence in exactly what will happen to ENSO in the future when it comes to climate change, even while they have high confidence that ENSO itself will continue. So it's a little bit iffy about exactly how it will impact, that climate change will impact the ENSO events, but it could strengthen or weaken the typical weather patterns associated with ENSO. So if we think about La Nina causing drier than normal weather across the southern tier of the U.S., if you include that with the drying effects of climate change and the warming of the atmosphere, then that might not be a good combination. That's just one example. Okay, so that's just an overview of ENSO. So hopefully a little bit of information the next time you hear it talked about, you might have a little bit of a better background. I do have some links up here if you want to look at those to get your own view of ENSO from these other resources. Now, if you want a lot of really scientific mumbo jumbo. You can go to that first one. That's the Climate Prediction Center's ENSO page. But what I like to read is the climate.gov ENSO blog. That's written more for the layperson, easier to understand. And of course, it has a great resource of previous episodes on their ENSO blog that you can go back and look at all the types of things they're putting out for ENSO. Climate Prediction Center's main page, you can get all the outlooks and other info on that page. Then if you want to see my attempts to translate these larger forecasts into just the Oklahoma version, you can go to our blog at ticker.mesonet.org, or if you want to sign up for the email version of the ticker, if you want to just get it in your email box each and every time I send that out, 3 to 4 times a week, you can just send me an email at gmcmanus@mesonet.org, and I will add you to the ticker email list. We have about 1,000 people from all walks of life in Oklahoma to get that. So it sometimes has good information. Sometimes it's just me talking on and on like I'm doing now. So that's it for what I have right now. And I thank you very much. And if anybody has any questions, if there's time, I'd be glad to answer them.
Okay, thank you, Gary. Appreciate you giving us an overview of the ENSO system. If you have a question for Gary, please put it into the chat box. While Gary's going to stop sharing his screen, we'll move to our next speaker and get it loaded up.
Working on it now. I'll be right with you.
We'll put a plug in for Gary's ticker. It's a very fun to read set of weather parameters there. So give you an outlook of what's going on for the day, first thing in the morning when he sends it out. So take a look at that if you're interested. Gary, we have a question. I don't know if you can see that, but it's what is our current ENSO number? If you're still on with us, Gary, he's taking a look. We'll let Gary answer that on the chat there. He's on the chat side, it looks like. So let's move on to our next speaker in the sake of time. Our next presenter comes to us from Washington, D.C. This is Brad Rippey. He's a meteorologist with USDA. And Brad is graciously joined us today, going to talk with us a little bit about the U.S. Drought Monitor and some of the financial assistance programs that might be available at USDA. So Brad, whenever you're ready, if you'll join our share your screen, we'll get started.
All right, I tried to share. I may have done it too early. Let me go back in if you're not seeing it.
Not seeing it.
All right, hold on just one second. This worked great when we tested it, so hold on just a moment. Sorry about that. All right, it should be shared now. And hopefully it's coming through. All right, we good?
Yeah.
All right, sorry about that.
Yeah,
there we go. All right, thanks Wes for the introduction. As Wes mentioned, I am a meteorologist by training. Went to Penn State. I currently work in Washington, D.C. for the Department of Agriculture. And on the side, I have been a U.S. Drought Monitor author. Actually, I'm an original author going all the way back to the beginning in the late 1990s. So it's been very interesting to watch the Drought Monitor evolve over the last 2 decades. See it being used more and more as a tool for disaster assistance. Today, I'm going to talk primarily about the Livestock Forage Disaster Program, but also touch on secretarial drought, disaster designations, and just a brief plug at the end there for the brand new Conservation Reserve Program, the CRP specification that was introduced in 2020. Jumping right in, I'm sure all of you have seen at some point the U.S. Drought Monitor. This is the very latest one, came out this morning. U.S. Drought Monitor made its debut way back in August of 1999. It was a multi-agency effort between government and academia to try to put all of the drought indicators together into a single snapshot. And it's not a type of product that you just like put all the data in, crank the You don't crank out a number. It's actually, there's some subjectivity to it. So you look at it from a convergence of evidence approach. We look at a lot of different layers of data, everything from soil moisture, to temperature, to satellite-based vegetation health, and a lot of things in between, and try to arrive at the best convergence of what the drought looks like in every given spot in the country. So over the years, we've seen the drought monitor being used more and more in disaster assistance programs through USDA. First used in 2003 for a non-fat dry milk giveaway, used again in 2006, $50 million in block grants across the Northern Plains during a time of drought. And then since 2008, we have seen the drought monitor used for payouts to livestock producers via the livestock disaster, the LFP, Livestock Forage Disaster Program. That has been, it was enacted, like I said, in 2008, but it has been followed up in 2014 and 18 in the two subsequent farm bills. So it's been in place now for well over a decade. If you look at the current drought monitor, we see more drought in the country currently than at any other time since late 2013, more than 7 years ago. And of course, a lot of that across the western half of the country, but extending out across parts of the Great Plains. If you look back at the history of the drought monitor, there's only two people that have done more shifts than I have. A couple of gentlemen from the National Weather Service Climate Prediction Center. So I've put in my time on the drought monitor over the years, over 100 shifts. Now, one of the things that I didn't mention earlier is that a lot of the data that we crunch to put together the drought monitor is we rank it using percentile rankings. That's the way, no matter what the period of record, whether it's 15 years, 30 years, 100 years of data, whether you're looking at soil moisture, precipitation, or vegetation health, we can put that into a historical perspective. And that's really the guts of the drought monitor. We have 5 categories. The low end category, D0, that is not drought, that's abnormal dryness going into or coming out of drought. We have 4 drought categories, D1 through D4. On the low end of that, D1 drought typically has a recurrence interval of once every 5 to 10 years. On the high end, a D4 drought, that's a 1 in 50 to 1 in 100 year occurrence, quite rare. One question we get a lot is, why have I had 3 or 4 D3s or D4s just in the last 20 years? Part of the answer is climate change. We are seeing a lot of whiplash weather in Oklahoma, elsewhere on the Great Plains. We really have truly seen some historic extremes, from wetness to drought and back again. So it really it kind of bends what we have seen anytime over the last 50 to 100 years in terms of drought intensity during some of these droughts that we've seen in Oklahoma and elsewhere. Getting into the subject for today, talking about the Livestock Forage Disaster Program, LFP, first enacted, Farm Bill of 2008. A lot easier to look at the provisions for that in graph form, where you see that in the 2008 Farm Bill, we had a pretty simple payout structure, 1, 2, or 3 monthly payments based on drought intensity. Nice little stair-step structure there. And then that was a pretty popular program over the first 3+ years of the LFP program. About $500 million in direct assistance paid out to drought-affected livestock producers across the United States. Of course, that 2008 Farm Bill expired September 30th of 2011, just as the drought was hitting the Southern Plains, the Texas, Oklahoma, New Mexico drought. So there was a gap where the payments stopped, and we were waiting and waiting for a new Farm Bill. That finally came in 2014. And the good news for livestock producers was that we had retroactive payments going all the way back to October 1st, 2011, made up a lot of that. People had to wait for the payments, but they did eventually come. The other thing that the 2014 Farm Bill did is it sweetened the pot a little bit for the payouts. The changes compared to the 2008 Farm Bill are highlighted in red on the screen. And if you put that in graphical format, you can see that the payment structure went to a 1, 3, 4, 5, where on the high end, if you were D4 for 4 weeks during the growing season, you had 5 monthly payments. There was a little bit of an anomaly that still exists today, in that we went from 1 to 3 payments, D2 for 8 weeks, that's a 1 monthly payment. And then that jumps to 3 payments for D3. I wish they'd kind of smooth that out. It creates some issues, but I'm on the operational side of things. I'm not on the policy or the political side. So I don't have much sway. If it bothers you, I guess you could talk to your elected officials. Maybe someday we can get that smoothed out a little bit. I think it'd make it easier for everybody. Now, since the enactment of the 2014 Farm Bill and with the retroactive payments, we've seen more than $7.3 billion go out the door to drought affected livestock producers since the October 1st, 2011 startup date, including more than $4 billion during the drought of 2012-13. In recent years, we've seen the numbers trailing off, with drought dropping to a very small percentage of the country, only about 2% of the country in drought in the spring of 2019. Numbers for 2020 are not complete yet. If you look at that over in graphical format, LFP payouts over the last dozen years or so, you can see the rise and fall as drought comes and goes. These are the US numbers. National, about $7.8 billion paid out through the Livestock Forage Disaster Program. If you look at Oklahoma alone, 1.5 billion paid out. So fairly substantial numbers, especially back in 2012 and 13. And of course, if you look at the numbers as a whole, I grabbed this slide from about a year ago, but we haven't had a whole lot of payouts in the last year, so it's still pretty accurate. Oklahoma, the #1 state in receiving LFP payouts, going back to the beginning of the 2014 Farm Bill, with about $1.5 billion going to the drought-affected livestock producers. And if you rank it, Oklahoma #1, topping Texas. That's good news, and far ahead of #3 Kansas. So it certainly has been an important program for producers with livestock in Oklahoma over the years. Now, I did want to briefly touch on another provision in the drought monitor that was enacted by then Secretary Vilsack and future Secretary Vilsack back during the 2012 drought. That is the fast track secretarial disaster designation process that used to require a gubernatorial letter to the Secretary of Agriculture, a very time consuming process. Now that fast track process is a nearly automatic D2 for 8 weeks, triggers a drought disaster declaration at the secretarial level. So that was enacted in the drought of 2012. And these are the counties. It also includes contiguous counties, which are shaded in the slightly lighter orange coloring. So you see the counties that have qualified as drought disaster areas based on the secretarial process for each of the 4 years, 12, 13, 14, 15. You can see the drought shrinking. And then 16, where we had almost no drought in Oklahoma, 17, 18, 19, and then lastly, 2020. So you can really see the shape of the drought from these maps. And you can see that the focus for drought in 2020 was clearly across the western half of the country. And then finally, I'll finish up with this slide. Just new in 2020, a new provision based on the US Drought Monitor. When you reach D2, that can open the door to emergency haying and grazing on CRP land. And these are the counties that have qualified for that based on the Drought Monitor depiction since October of 2020. So that should remain in place for the future as well. So again, Drought Monitor, only 20 years old, but has certainly been used quite a bit by USDA for disaster assistance, particularly when it comes to livestock producers. I'll finish up there.
Okay, thank you, Brad. I'm sure there'll probably be some questions related to his presentation. So if you can't see the text, I'll read them to you if something comes across here. I see Gary's had some conversation about the ENSO pattern in the chat room. Questions for Brad?
I'll keep an eye on the chat as we move forward.
You've got access to the chat. Brad, I'll start a question. I was doing a presentation earlier this week in the Oklahoma Panhandle, and the question that I've gotten several times before is, what sources of rainfall data do you use to impact that drought monitor? Their concern was, I don't live next to a Mesonet tower or a co-op site. What can I do or what sources do you use?
We use pretty much anything that is ingested into the National Weather Service data feed. And one thing I would recommend to anybody who feels like they're not being listened to in terms of their rainfall data, look into CocoRAS, which I can get a link typed into the chat box. That is a citizen science program. You use a manual rain gauge, a 4-inch plastic rain gauge, real easy to mount on a fence post or just somewhere out in the open. And that is especially if you report more than 90% of the days, if you're a reliable observer, that is a great way to get your observation into our drought monitor database through the National Weather Service. I've been an observer myself going back about 12 years now, since it expanded out of the original Colorado area. And so that would be one of my recommendations, is look up COCORAHS, cocoras.org. And costs about $30 to buy yourself a rain gauge, and next to nothing after that, just to set it up and report rainfall daily.
Yeah, very good point. Here in Oklahoma, we have a co-worker here at the Oklahoma Mesonet that coordinates CocoRAS for the state of Oklahoma. A little bit of a plug, there are about 220 observers on that CocoRAS program. Unfortunately, 3 out of 4 of them are in Oklahoma City or Tulsa or Norman. So if you're a ranch owner in one of the less populated areas of the state, we could certainly use some help to go along with some other sources of rainfall data to impact things like the drought monitor. Ask for a URL for that in the chat. Brad, if you could put that CocoRAS URL in there if you can. Somebody beat you to it, maybe, possibly. You can always contact Gary or myself here at the Oklahoma Mesonet, or Andrea Melvin that you see in our chat rooms, and other coworkers of ours, and we can get you in contact with the information you need on CocoRAS as well. So any other quick questions for Brad before we move on? All right. Brad, if you're willing to stick around for just a little bit, observe that chat room, there may be some additional questions. I'll be finishing up today. We're going to visit a little bit about Mesonet. So I'm going to try to start my screen. Hopefully you can see, Brad, I can still see your face. Is the Oklahoma Mesonet still up on the screen okay? Yes, it is. Okay. All right. Well, as I was introduced earlier today, my name is Wes Lee. I am the agriculture coordinator here at the Oklahoma Mesonet. We're headquartered out of the National Weather Service in Norman, but it is a statewide project that is jointly run by Oklahoma State University and OU. OSU brings in the agriculture side of the equation, and OU is primarily interested in public safety. You'll see here on this slide that the Oklahoma Mesonet started in 1994, January 1 of 1994. So if you happen to be interested, we can get you weather information on a 5-minute interval if you're interested, going back all the way to 1994 on most of our Mesonet towers. Okay, here's a picture of the towers we have across the state. We currently have 120 towers. There is at least one in every county of Oklahoma. A lot of counties have 2 or more. Payne County, for example, close to Stillwater, the university, there's 4 towers in that particular county. Most of these towers are located on private lands. In there, the remainder of them are scattered around on things like research stations and public lands across the state. Over 100 of these towers are original, back to the 1994 date. The other 20 or so towers have either been added or have had to change due to some kind of complication that arose over that about 27-year period. At the Oklahoma Mesonet, we measure just about any kind of weather information that you might be interested in. You can see from this list here. And looking over at the tower, I don't know if you can see my cursor, but most of the instruments we have a duplicate of. For example, at the bottom of the tower at 1.5 meters, we have an air temperature measuring device, and also at 9 meters towards the top of the tower. So each one of these measurements that you see here, air temperature, rainfall, etc., are recorded every 5 minutes. We utilize either two-way radio or cell modems on each one of the sites to send that information to us here in Norman, and then we very quickly get it out to you on whatever platform you're using to take a look at that information. So 5-minute data on most of the parameters that we record. Soil temperature takes a little bit longer to record, so about 10 minutes, 15 minutes on our soil temperature, we get an update on that. And soil moisture takes a little bit longer, about 30 minutes to do it there in the state. Now, to present that information out to the public, we use lots of different delivery formats. I like maps, and we'll focus more on maps today than anything else, but we have hundreds, possibly even 1,000 maps on the website to take a look at. Other methods are mediograms, charts, and graphs for you to obtain some information. The best way to see our information is to go to the website, as you see here, mesonet.org, mesonet.org. From that location, you'll have access to all of the information that's recorded on our weather system across the state. Most of the weather variables you'll be interested in would be under this weather tab. So if you'll click on that weather tab, it'll open up a whole list of weather variables for you to choose from to take a look at the different delivery formats that might be available. We'll start off with rainfall maps. I counted yesterday, we have 61 different rainfall maps. Most of them are updated every 5 minutes across the state. You see the actual numbers on the map here on this 30-day rainfall accumulation map. That's the actual Mesonet towers across the state measuring that 30-day rainfall. But you'll also notice some colors on the map. That comes to us from the National Weather Service River Forecast Office out of Tulsa. And what they do, they take the radar data that they have and use our Mesonet tipping rain gauges, the 120 rain gauges across the state, to validate that radar. And then they overlay this color map across our state. Now, this doesn't happen instantaneously. It takes a little bit of time. But once it hits the screen here and you see the colors, you can feel pretty confident in the quality of that data between our Mesonet towers to give you an idea of what kind of rainfall might be going on there. If you zoom in on these maps, you'll notice it's pixelated, and each one of these pixels represent the resolution at a 2.5 by 2.5 mile square to give you an idea of rainfall that's going on. And again, we have rainfall maps from everything from the last hour to the last year and just about everything else in between. Now, very important to Oklahoma farmers and ranchers are some weather data that not every weather system out there in the state takes the time to record, but we do here at Oklahoma Mesonet, including soil moisture and soil temperature. Here's an illustration of our soil sensors that are in the soil at 2-inch, 4-inch, 10-inch, and 24 inches at almost every site. And notice that they're underneath the native vegetation or sod located where that Mesonet tower is at. We also have a set of sensors underneath chemically treated bare soil to better represent what might be going on in a conventional tillage type situation out there in the field. Now, to present that soil moisture information, we use primarily two different formats. One is plant available water. Now, plant available water is simply just the inches of water that might be available in a section or a slice of soil down to a certain depth. So if we start here with the 4-inch plant available water, you'll see that it's a slice of soil from the surface down to 4 inches. It utilizes a sensor in the middle at 2 inches, along with a complex algorithm to try to estimate what is the inches of water available in that entire slice of soil. If we go to a deeper plant available water, like the 16-inch, it utilized both of these sensors to tell us how much water is available for plants between the surface down to 16 inches. Now, a couple of drawbacks to plant available water is that if this surface sensor, this 2-inch sensor, happens to be frozen or inoperable, then we don't have a plant available water reading on that particular day. Another what I would consider to be a drawback is plant available water is very soil texture dependent. So in another part of our website called the About tab, you can find soil texture for each one of our 120 Mesonet sites across the state. If you happen to have a different soil texture, and you probably will, than your closest Mesonet site, then the plant available water might not be totally the same as it would be at the Mesonet weather site. The other way that we present water information is with fractional water index. It is a scale from 0 to 1, 0 being as dry as the sensor can read, and 1 being as wet as that sensor can read. Now here we do not try to estimate any water anywhere else in the soil profile. It's simply a measurement at the sensor site of how wet or how dry it is across the state. So let's take a look at some of the maps that were generated using these soil moisture probes. We'll start off with a plant available water map. All of the maps I'll show you here are at the 4-inch level. This is a one-day average map showing plant available water. The numbers you see are, of course, inches of water available to plants in that 4 inches slice of soil from the surface going down. Notice in the Oklahoma Panhandle and some other counties in the Northwest, we're missing some numbers. You know, we do have Mesonet towers in every county, so we know that we're missing numbers there. That is because on the day I generated this map on January 26th, we had some freezing soil temperatures, or it doesn't actually have to be freezing. It can be below, I think the cutoff temperature is 34.3 or colder than our soil moisture sensors stop operating. So that 2-inch soil moisture sensor was considered to be frozen at that situation. The second map here is we take that same plant available water and we put it on a percentage. So 100% would be the maximum soil holding capacity, and 0 would be a dry soil. So it gives you a little better representation of how you may be compared to another part of the state out there looking at that percent plant available water. Our maps are all color coded, so the green indicates the wetter soils, and the reds or browns the drier end of the soil profile. Moving over to the fractional water index, you'll see the first one here is a 4-inch fractional water index, 0 to 1 underneath sod. If it doesn't say anything, it'll be under sod there. So you can see that the main part of the state is mostly 0.9 to 1. So very good shape on a lot of the state. The Panhandle has some issues out there. We get out there to the tip of the Panhandle, we're not picking up any moisture at the 4-inch level. And if we looked at deeper soil probes, even in the main part of the state, we would see some of those drought areas starting to show where we've got some moisture concerns still to deal with. The last map here to show you is our bare soil. So you can kind of compare the difference between soil moisture under sod and soil moisture under bare soil at that 4-inch level by taking a look at that. Okay, let's go back to the mesonet.org website. Another region that you can gather a lot of information for farms and ranches under our agriculture tab. I might mention that I am locked on to the Stillwater station here for this presentation. You see by the blue box it says Stillwater, but if you clicked on that box, you could easily select any of the 120 towers across the state to take a look at. So once we open the agriculture tab, we get what's called the farm monitor to take a look at. Now, a lot of producers like to leave this open and running on their screen because it gives them a lot of information about the weather at a glance for their particular Mesonet tower that they're closest to. I've starred or added a blue star here to 6 different features of this Mesonet monitor page that all deal to some measure or other with soil moisture to take a look at. Since we're talking drought today, let's click, we would click here on the drought tab, and it would open up a drought page that you can get access to those drought maps that Gary and Brad were talking about. We'll start with the Oklahoma Drought Monitor page. This is, as Gary mentioned, and maybe Brad as well, that they're updated every Thursday morning. So this is a fresh map, hot off the press. You can see the parts of the state that have the color indications and what level as Brad visited with you about, between the D0 and the D4 levels of the drought going on in the state. You can also access that U.S. drought monitor map that Brad showed you. Again, he mentioned it updates every Thursday morning, so you can get a picture of what's going on in the state or in the nation. Fortunately, we've missed most of the drought that's occurred in the Southwest, but you can see from this national map that we're just barely out of the major drought-stricken areas of the country as we speak. Now, the last map I want to show you here in another part of the website, it's actually in the forecast section. You'll have to click on the forecast tab, but you can get some long-range forecasts from the National Weather Center. The one I pulled up here is a drought forecast going through the end of April. So if the predictions are right and the La Nina pattern tends to give us the kind of weather patterns that it normally does, we'll tend to slide more into drought into looks like about the western third of the country. Now, a month ago, they were showing almost the entire state of Oklahoma being in some kind of drought by the end of spring. So this is an improvement, but it still shows that we've got a long ways to go to get to planting season before we're out of drought issues. Now, everything I've showed you has been on the website, mesonet.org, but we also have a platform out there for smartphones, Apple and Android phones. Just go to the App Store at either one of those platforms and type in Oklahoma Mesonet, and you'll be able to get the app on your smartphone to take a look at the weather information. Here's what it would look like on I think this is an iPhone 10, but very similar on all of the phone platforms. It's going to default to Norman because that's where we're headquartered out of. But if you'll click on this little blue ship wheel in the upper right-hand part of the cell phone screen, it opens up the page that you can very easily change to the other 120 sites across the state. Now, it will stay on the site that you select until you change it manually again yourself. So down at the bottom of the opening screen, you'll see you have access to the National Weather Service radar, the advisories, and a little map page where you can get access to all of those weather maps that Oklahoma Mesonet generates. Again, most of those are updated every 5 minutes. With that, I'm going to end the presentation about Oklahoma Mesonet. Stop sharing my screen. We'll get back into the chat section. We definitely wanted to get done and get you out of this session before 12:30. Before 1:30. I want to invite you to come back and join us next week. We'll have 3 speakers talking about some production management techniques you can do if you happen to be experiencing some drier than normal conditions on your ranch. And keep in mind that even though you may not be experiencing drier than normal weather right now, chances are it won't be very long until you're back, your part of the state is back in a drought again. So let's check out our chat room, see what we've got going on. We've got a couple of messages here. Gary, I hope you're still on. Or Andrea, I'll read them in case you can't see them. How well does soil temperature and moisture on Mesonet sites correlate to soil on well-managed grazing lands nearby? Well, I'll make a stab at answering that. Unfortunately, rainfall tends to be pretty spotty in Oklahoma. So just a half a mile away from the Mesonet site, you may have experienced more or less rain, and it also depends dramatically on your soil texture and how fast that water can penetrate into your soil location, as long as other things as well as slope and other information like that. But I would say that we're fortunate in Oklahoma to have that 120 sites, better than pretty much any other part of the country, to give you a pretty rough idea, but a good idea of what might be going on close to your Mesonet site that you could adjust based on the rainfall that you receive. How is snow calculated into the drought maps? Gary or Brad, would you like to stab at that? I see you've answered it on the chat room, but would you like to verbally answer that?
Yeah, I took a crack at it in the chat, and the short answer is that we count the snow as it falls as precipitation, and not so much in Oklahoma where it tends to melt fairly quickly, but up north that can be a bit of a problem where the snow just sits like it has in Minnesota and Wisconsin and the eastern Dakotas for weeks or months. So it does create some problems, especially if that snow happens to sublime, which can be a problem where it never actually enters the soil. So there are possibly cases where a fluffy snow might fall, it never actually reaches the soil. So we count it as precipitation, but it may never reach the soil. So it can be an issue at times that we may not properly count that. I think there's warm, dry springs where that may be an issue, where drought develops faster than we expected. Something we're always trying to fine tune with the drought monitor. And it's a good question because it is an issue, especially up north and on the high plains.
Yeah. In Oklahoma, we, as Gary has posted in the chat, we don't use heated rain gauges. So we do have about an 8 to 10 inch capture cone on the top of our rain gauges. So as long as it doesn't snow more than that at one particular time, as that snow melts, you'll see rainfall data several days into the future. For example, on Tuesday, it rained snowed a couple of inches in the Oklahoma Panhandle. And if you look at today's rainfall map and probably tomorrow's, you'll see a little bit of rainfall precip that's coming from that little bit of snow melting that came on Tuesday. Any other questions for the three presenters that are still online? If so, quickly enter into the chat room. If not, again, invite you to come back and join us next week. I think we got 3 very good presenters for you to listen to give you hopefully some practical information that'll be useful to you. So
for sure. Thank you all. Weather's really interesting, and that's probably a good reason why we had a terrific turnout here today. Wes, Brad, Gary, Andrea, thank you all. Tremendous presentations. I'm just going to let my other colleagues here make a comment, and I'll just say and sign off. Thanks so much for joining us. Hope you can join us. Some of the speakers for next week are some of the best in the business related to either beef nutrition or forage management. So don't laugh, Dr. Beck. It's the truth.
Thank you, Wes. I really enjoyed it.
Certainly appreciate our presenters today. Also make sure that we recognize a few that have joined us. We've got Department Head for Animal Science, Dr. Clint Rusk is with us, and certainly looking forward to next week. Wes and the group today have done a fantastic job. Thanks for taking the time to really be with us. We do ask that attendees, if you have a moment, please fill our survey out at the conclusion of the presentation today. As you leave the meeting, it should automatically pop up for you. Really looking for that feedback. We got some good feedback last week, and so thanks to you all for that. After I'll put one plug in, since this is just a two-part series, we do have a show cattle fundamentals series coming up at the conclusion of this two session series. So look forward to that as well. Thanks so much, and we will see you next week. I'll turn it back to you, Dr. Lawman.
All right. No, I don't have anything further. So y'all have a great day, and hope you get plenty of moisture this week in your area.